So the first thing we need to do is define the difference between an equation and an expression. So you can see over there on the left-hand side, expressions do not have an equal sign. So saying something like x plus 2 is an expression. An equation has an equal sign. So saying x plus 2 equals 5. Equations we can actually solve and get an answer, whereas expressions we cannot. Let's talk about combining like terms. So combining like terms essentially means picking out your pieces of your expression that are the same that we can put together. Terms are simply like the pieces of your expression or like the pieces of the puzzle. So we have 2a, 5b, 9c, and 100 are all considered terms. Now the numbers that are in front of the terms are your coefficients. In terms of the process of combining like terms, you're not really doing anything with the variables. It is the coefficients that are out front that you're actually combining together. When you have a number that's by itself with no variable attached to it, that's called a constant. Now, like terms have the same exact variable being raised to the same exact exponent. So I give you some examples of like terms on the left-hand side. 3x and 2x could be combined together. 8y squared and negative 5y squared could be combined together. Things that are unlike terms, things that have different variables are unlike. Things that have the same variable but being raised to a different exponent are unlike. So we wouldn't be able to combine those together. So let's look at some examples. When combining like terms, you're essentially, like I said, picking out your pieces of your expression that are alike that you could put together. So notice we could combine 8x, we can combine a positive 2x, and notice how I circle this next one. I don't just circle it as 3x, I circle it as negative 3x. I always tell students when you are combining, the easiest way to go about doing it is just to always add. But you got to be careful with your signs. So like I said, when I circled 3x, I didn't just circle it as 3x, I circled it as negative 3x. So we're combining 8 plus 2, which is 10, and then 10 plus negative 3 is going to give me 7x. Now I can combine negative 5y and positive 10y. So again, notice I took the sign that's in front of it. Negative 5 plus 10 is going to give me a positive 5y. So if you're left with a positive, you put a plus sign. If you're left with a negative, you put a minus sign. This is your final answer. You can't do anything with x's and y's. You can't combine them together, so you're done at this point. Combining like terms with this one, I've got 8y and I've got a positive 10y. So 8 plus 10 is going to give me 18y. Notice I don't change my variable when I'm combining. I just leave this y. And then I've got negative 3y squared and negative 6y squared. So negative 3 plus negative 6 is going to give me a negative 9y squared. Again, I can't combine these because they have different exponents. This would be my final answer. Now, order really doesn't matter when you're writing your final answer. In future math classes, like if you go on to take pre-calculus, they're going to want you to write the highest exponent first. But in terms of our class, really whatever order you write it is fine. Now, there's a big difference between combining like terms, which is adding, and then multiplying terms. Unlike terms can be multiplied together, and they can be multiplied using the associative property. So if you had something like 2x times 3y, again, these can't be added, but they can be multiplied. So essentially what you're doing is the 2 times 3, which is going to give you the 6, and then x times y, again, you can't really multiply them together, but you can write them side by side, indicating that they're being multiplied together. Now let's talk about multiplying variables. So we know that 3 times 3 can be written as 3 to the second power. So when you have x times x, that can be written as x to the second power. But what about if you had something like x squared times x? Like, what does this mean? You got to really think to yourself, how many x's am I multiplying together? Well, x squared means x times x. And then times another x is like, well, how many x's am I multiplying together? Well, x times x can be written as x to the third. Let's look at another example. If you had x squared times x to the third, again, really the question you got to ask yourself is how many x's altogether am I multiplying? Well, 3 x's multiplied by 2 more x's gives me a total of x to the fifth being multiplied together. The distributive property utilizes the fact that you can multiply terms together. With the distributive property, what you can do is take any term that's written outside of a set of parentheses and distribute it or share it to each term that's inside the parentheses. So A being multiplied by B plus C can be rewritten as A times B plus A times C. The main thing is that you take this number or this term and you make sure to share it to everything that's inside the parentheses. So let's look at some examples. In this one, you're taking 4x and we are multiplying it by each term inside the parentheses. So 4x times 2y is going to give me 8xy. And then 4x times, be careful here, it's not just 7, it's negative 7. 4x times negative 7 gives me negative 28x. Notice my variables just get tacked onto the end here. Signs are going to be important with this one. Negative 5a times 8a. So negative 5 times 8 gives me negative 40. And we just talked about this a while ago. A times a is 2a, so a to the second power. Negative 5 times negative 10c. Negative times a negative gives me a positive 50. And then a times c can be written as ac. This one, a lot of students are like, well, what is it that I'm distributing? Essentially, all you're doing is taking a negative 1 or a negative and distributing it to both of these two. So negative times y gives me negative y. You just want to be careful with signs because negative times negative 1 gives me a positive 1. So essentially what just happened is the signs changed for both of these two. Now we're going to kind of combine these two concepts together. We're going to distribute and combine like terms. The first thing you're always going to want to do is distribute any numbers that are outside of your parentheses. Now in this example, 8 only gets distributed to what's inside the parentheses, not these two terms over here. So that's what I'm going to start with. So 8 times 2x gives me 16x. 8 times negative y gives me negative 8y. Now notice what I'm going to do is I'm going to drop these two terms down, just basically bring them down as part of my problem. Oops, that's supposed to be a 7, not a 5. Now what I'm going to do is exactly what I was doing a couple of slides before. I am going to look and scan my problem and see, are there any like terms that I can combine together? So I can combine 16x and positive 5x, which is going to give me 21x. I can combine negative 8y and negative 7y, which is going to give me negative 15y. And that's going to be my final answer. In this one, I'm going to start off by distributing not just 4. Again, always take the sign that's in front of it. I'm going to distribute negative 4 to both of these two. I'm not distributing 5x. 5x just gets dropped down. It's whatever's right outside my parentheses. So this is negative 4x. Negative 4 times negative 2 gives me a positive 8. I'm going to bring everything else down, so the 5x and the negative 2y. Combining my like terms, I can combine 5x and negative 4x, so adding those together gives me just a positive 1x, or you could just write x here. These two can't be combined together, so I'm just going to rewrite them as part of my final answer, and then I'm done. Now let's talk about what it means to solve equations. So everything we've just dealt with has been an expression. Expressions mean you can just combine like terms together. You can't really solve anything. To solve an equation means to find all the possible solutions to make the equation hold true. So for example, x plus 2 equals 5. We can probably just look at that one and tell what the answer is. We can say, okay, x is equal to 3 because 3 plus 2 is equal to 5. To find solutions to an equation, we isolate the variable. That means to get the variable by itself. No coefficients, no other numbers with it. So to say something like x equals 3 means that x is by itself on this side of the equal sign. The addition principle states that if a number is being added to both sides of the equation, what we can do is do the opposite and subtract that number from both sides of the equation to isolate the variable. So let's look at this example. X plus 5 equals negative 10. Well, if you want to know what plus 5 equals negative 10, we can do the opposite and subtract 5 from both sides to see what that mystery number is or see what x is. With an equation, whatever you do to one side of the equation, so if we want to get rid of this by subtracting 5, we have to do the exact same thing to the other in order to keep it balanced. So now we've isolated x. Negative 10 minus 5 gives me negative 15. Now, we can check our equations. So if we plug negative 15 back into the equation and say negative 15 plus 5, we'll say, okay, does that equal negative 10? In this case, it does. So the nice thing about equations versus expressions is that you can actually check your answer. Now, anytime you have addition or subtraction equations, some steps that you can follow is you want to find the side of the equation that has the variable. Ask yourself what is preventing that variable from being by itself or being isolated. We're going to do the opposite or add the opposite of that number to both sides of the equation, and then we're going to check our answers. So let's look at these examples. 14 is preventing x from being by itself. So instead of adding 14, I'm going to do the opposite and subtract 14 from both sides. And we get x is equal to, you could treat this as negative 20 plus negative 14. You can treat it as negative 20 minus 14. It's going to give you the exact same answer. So we're going to get negative 34. To check your answer, plug negative 34 back in for x. And we say, okay, negative 34 plus 14, does that equal negative 20? Yes, it does. So this checks out. This one, we can add 9 to both sides to get rid of it on this side of the equation, and we get x is equal to 65. To check our equation, plug it back in. 65 minus 9 does give me 56, so our answer does work. Now this one, be careful. You always want to take the opposite of that number to get rid of it. So if I want to get rid of negative 18, I would add a positive 18 to both sides. That's going to get rid of it on this side. And I get x is equal to 18 plus negative 2, which is going to give me 16. Plug it back in, see does it work. Negative 18 plus 16 does give me negative 2. So this does check out. Now to solve multiplication and division equations, it's the same concept. Find where the variable is, ask yourself what's preventing it from being isolated. Now if that number is being multiplied, you're going to do the opposite operation, which is divide. If the number is being divided, you're going to do the opposite operation, you're going to multiply. Then of course you can check your answer. So let's look at some examples. In the first one, ask yourself what's preventing x from being by itself, which is the negative 4. This indicates multiplication when they're side by side. So the opposite of multiplication is to divide. So we're going to divide both sides by negative 4. Now notice I didn't change the sign like I did with addition and subtraction. Multiplication and division are opposites of each other. So if you're multiplying by negative 4, to get rid of it, the opposite is divide by negative 4. Again, don't change the signs. So negative 20 divided by negative 4 is going to give me 5, positive 5. Check my answer, negative 4 times 5, does that equal negative 20? And yes, it does. So this one checks out. This one, x is being divided by 9. So the opposite of dividing by 9 is multiplying by 9. So I'm going to multiply by 9 on both sides, which gets rid of it over here. Negative 14 times 9, if we multiply those out, that's going to give me negative 126. If you check your answer, we can plug negative 126 in and divide that by 9. So negative 126 divided by 9 is going to give me negative 14. So it does work. This side, x is being divided by negative 6. So the opposite of dividing is multiplying. So I'm going to multiply both sides by negative 6. Negative 6 times negative 2 is going to give me a positive 12. Check our answers. Plug in 12 divided by negative 6. Does that equal negative 2? And yes, it does.